Thank you for being here. Thank you for sticking around. I'm going to move out of the way and let Blair share his screen and share with us. Hopefully we won't run too late, but we'll record it and share around. I'm so excited. Blair, thank you for this amazing work. It's a long time coming. Nothing that a few minutes of Zoom delay will prevent us from hearing. So take it away, Blair.
Perfect. Yeah. I don't know. I feel like this actually is the perfect start to a talk. It feels like having a Zoom call with my mom or something. So this is like a family, intimate family affair here, where we can tell you just a little bit about a little project that we did. Kyle, I think, is here with me. Hopefully, we can get Kyle permission to share as well if needed. But Kyle is here with me from the University of Texas at Dallas, and I am at the University of South Carolina. We are two of the 8 authors of the Replication Study of Operations Management, Experiments in Management Science. And I'll tell you a little bit about it today. Just to make sure I'm planning appropriately here, should I be leaving time at the end for, it's an hour session with some time at the end for questions, or questions throughout, or?
Yeah, it's up to you. I think maybe because of time that we lost, why don't you deliver the majority of it, and then depending on if folks stick around, you can go for questions. It's a little bit up to you, Blair.
Perfect.
Yeah.
Perfect. If you want to put questions in the chat or something, maybe I could ask Kyle to kind of monitor that. Anyway, I will continue on here. So here is our plan for the day. And so let me just get right into it. I'm having a little bit of an issue with my, hold on for 1 second. There we go. Okay, so
You see it well.
Very good. So we're gonna, let me just talk about the motivation here. Why do we want to conduct a replication study in the first place? Obviously, we began talking about this several years ago when issues of replication and data scientific integrity were not in the news on the daily. But so why would we want to conduct a replication study? I think there's kind of 2 answers to this question. One is just kind of fundamental to the reason that we do experiments in the first place, and the timing seemed right back then, and maybe now seems even more right today. The philosophical reason is that replication is at the heart, is one of the strengths of laboratory experiments. So this handbook of behavioral operations came out a few years ago, 5 years ago or something. 2 of the 3 editors are co-authors on this very paper. And if we just begin reading the book, it's only like 600 pages. So let me just start on page section 1.1 here. We say that behavioral operations management started in order to first test and then improve modeling assumptions about decision-making, which makes it, I think, an adjacent field, an appropriate topic to share with you all today. The ability to cleanly establish causality is a relative advantage of laboratory experiments compared with other empirical methods. I think randomized assignment to treatments is the gold standard for establishing causality. And this is what we're almost always talking about when we publish our papers, that laboratory experiments are really, really good at disentangling possible explanations for causality. But also here on the second page of this book, we say another advantage of laboratory experiments is that they lend themselves well to being replicated by researchers in different laboratories. Replicating results is important because any single laboratory result can be the artifact of protocols or settings in the specific laboratory. And while we talk about this as a strength of laboratory experiments, the truth is that we don't do it that often, or at least we don't publish it. I think we put a premium on new, interesting results that are able to establish causality, and historically maybe don't value so much replication. But perhaps things are changing. We'll see. Why do a replication? Answer 2, kind of tactically, the time was right. So we have the field of behavioral operations management had been around for 20 years. We had gathered enough behavioral laboratory experiments that we could put them together in one big project. Synthesizing results can be useful. And perhaps most importantly, the editorial board of management science called for such a project. And so we decided to answer the call. So in late 2019, David Simchi-Levy, newly installed editor-in-chief of management science, said in a recent analysis, in his blog post, he said, in a recent analysis done for management science 65th anniversary, it was found that 60% of papers in 2018 include real-world data and 15% include laboratory data. Data credibility and reliability was a real thrust of his tenure, has been a thrust of his tenure. He said, moving forward, I have a wish and a challenge. I wish to appoint a management science data editor, and a challenge for the management science community. The editorial board would like to publish a paper, probably fast track, that reports the replicability of laboratory experiments published in management science. This was done, see camera, these were published in Nature and Science, and it's time to do the same for management science papers. And so we put together a team, and we decided to try and answer David Simchi-Levy's call. The team is 8 researchers from 5 universities: Cornell, Michigan, UT Dallas, University of South Carolina, and Wisconsin. We established the following goal for ourselves. We said that we want to design, we wanted to solidly establish or not key findings of highly impactful experimental papers in the journal Management Science through high-powered replication across multiple locations using original materials when possible. We'll talk more about that in just a moment. So ours is obviously not the first replication, not by a long shot. There has been a growing body of replication efforts. Here were a few of the ones that kind of we were paying most attention to as we developed our own. So the first one is this reproducibility project in psychology. It is involved 100 papers, replicating 100 psychology papers. It was a decentralized affair, so researchers who were interested in participating were able to kind of adopt a project. In total, there were 270 authors. Each paper was replicated at one site, and so the list of papers available was kind of mechanically determined. So it was in order to avoid kind of cherry picking papers. They did as follows. They said they started with the year 2008. They said papers published in 3 key journals that I think touch on 3 different streams of psychology were going to be included. And so they created a list of papers starting with the January 2008 editions of these journals, and they made available like 20 papers at a time, allowed interested labs to adopt papers, and then when they were running out, they added another 20 papers or something. And so in this fashion, they had this rolling window where something like 70% of the papers published in the first few months of 2008 in these 3 journals were replicated. And so, and what they found was that the success rate was something like 36%, and this made news. The paper was published in 2015. So there was several follow-up papers. The EERP, Experimental Economics Replication Project, was a more centralized affair, 18 authors replicating 18 papers. Again, each one was replicated at one site. Here we had basically 100% coverage. So this included all of the between subjects lab experiments published in the 2 journals, AER and QJE, in the years 2011 to 2014. And the replication rate was a bit higher there. And the Social Science Replication Project, also David Kammerer and company, 24 authors replicating 21 papers. Again, all of the experiments published in the years 2010 to 2015. I have a typo here. So these last 2, EERP and SSRP, went for, all of these included a mechanical selection process. Okay, so then we have another paper in our own field, a relatively small replication project. This was intentionally a kind of close replication. The interest here was, could we replicate results that were originally done in the lab if we take them onto mTurk? And so this was more of a curated approach. They chose 3 representative papers and replicated them, and found that 2 of the 3 replicated when taken to mTurk. So these first three were, the goal, I think, was exact replication, to take the original materials and test them in the same modality. The second one here was, the aim was a close replication to see if things would replicate on MTurk. And then we have this sequence of psychology studies called the many lab sequence, where, again, these were highly decentralized with between 50 and 200 authors per paper. And the goal here was to take a curated set of results and to test them in every single one of these labs to see heterogeneity across labs. So you can see here that we have these papers tested between 10 and 30 results that came from like nearly, I don't know, 80 years and dozens of journals. And so they were kind of curating effects that they thought would be interesting or important to test. And so here we see a tension between this mechanical selection of papers versus a curation. Curation means that you can pick important results that are going to be of interest to the field, whereas the mechanical approach means that, you know, it has to be somewhat arbitrary. For example, this RPP, the giant replication study in psychology, 100 papers, but they just arbitrarily came from the first few months of 2008. Okay, so this informed some of our thinking here. One other note, of course, this many labs project, they were replicating the same result in many different labs, and this seemed like a strength of their approach. Okay, so our initial objectives here were to replicate between 8 and 10 papers published in the journal Management Science. We wanted to achieve a 90% power at the 5% detection level, and we wanted to attempt each replication at 2 of the research sites. We wanted to do this to try and add even more robustness to the results that we were able to find. So first we had to establish a list of candidate papers. Then we had to narrow the list based on community feedback. So the establishing the list of candidate papers was kind of a mechanical process. We wanted to choose all papers that had a kind of standard subject pool, that had a between subjects experimental design with laboratory, with undergraduate student or with university students, or conduct on MTurk, both of which we could replicate. Narrow it down based on community feedback so that we could have a little bit of this curation, but it's not us curating the list, but we wanted to have others in the field curate the list so that we were replicating papers that they found useful and important and interesting to them. Then we had to assign the papers to replication sites, establish the protocol, solicit replication rates from the community. We were interested in seeing how did the community members anticipated replication rates match with actual replication rates. And then we actually compiled the replications and conducted the replications and compiled the results. So step 1 was establishing this list of candidate papers. We tried to kind of bin them into several kind of key areas of interest: inventory, supply chain management, forecasting, queuing and production, sourcing and procurement. Papers that involve specialized subject pools like managers with, at least 5 years of supply chain experience or something, we excluded because that was going to be infeasible. And we were interested in those that had been, we looked at citation count and citation rate to see what we thought would be most interesting to our community. In September, October 2020, we surveyed the MSOM Society sections. We included these 5 areas. We gave a survey asking for what these community members would like to see replicated, and we received 100 unique responses. So it looked like this. For each of these 5 categories, we listed out 4 or 5 papers. Most categories had 5 papers, and we asked people to select up to 2 papers from this category that they would like to see us replicate. So they could have clicked on 0, 1, or 2 of these checkboxes for each of the categories. And so we took the top 2 from each category. And so that gave us a list of 10 papers, and we thought that that was going to be feasible. So we moved forward with this list of 10 papers, 2 from each category. So then these were the 10 papers that we decided to replicate. We're going to refer to them by these handles here. And so then we had to assign these papers to our 8 authors across 5 universities. We took the 8 authors and we paired them into 4 teams. 3 of these teams were natural fits because we had 2 authors from each university. Andrew Davis and I paired up because we are both 6 foot 6 inches tall. And so we were the team tall guys. Okay, and so we were going to replicate 10 papers. We were going to replicate each one twice. That's 20 individual replication efforts. And we had, and so we had to assign these to each of the 4 teams. That means that each of the 4 teams is going to be doing 5 things. And we assigned a primary team and a secondary team to each paper. Okay, so here were the primary and secondary teams. The primary team was in charge of reaching out to the original authors, asking for original materials, getting them up and running. And the secondary team was in charge of kind of assisting and overseeing things. And then the secondary team ran the replication at their site as well. So that means that each team was either the primary team for 2 or 3 papers and the secondary team for 2 or 3 papers. We got the original materials from the authors if possible. Sometimes they were lost. Sometimes we had to update them. We tried to use the same participant pool. We did not allow authors to attempt replicating their own papers. Some of the authors in the project were the authors of original papers, so we didn't let them have any role in that. We calculated the sample size. We were aiming for a 90% power or better. When we did this power analysis, we found that some of the target sample sizes were very, very small because some of the original results were very, very strong. And so we wanted to add some additional criteria. When we say high powered, we mean that in the statistical sense, but also just kind of in common sense as well. And so a sample size of like 5 people didn't seem like it would be a high powered replication, even if it did achieve 90% power. So we said it had to achieve 90% power and also be at least as large as the original sample size and also be at least 40 subjects, whichever, it shall not be smaller than any of those things. And so here we have our original sample size and our target sample size for each paper. We pre-registered on as predicted with the hypotheses, sample size, protocol, etc. And we posted all this to a website, MS Replication. We'll take a look at this website if time permits, but we'll see. And then we solicited community feedback for replication rates, asking folks what they thought the likelihood was that each of these papers would replicate. We developed a partial replication report at this point, and we sent this to the original authors. So this talked about the power analysis, talked about the hypothesis that we were going to test and how, a little bit about the materials and the procedure, but it did not, of course, include the results because we hadn't yet run the replication. We just had planned ahead. We sent this to the original authors so that they were aware and had an opportunity to discuss with us before we actually ran the replication. The project was initiated in 2020, January of 2020. Of course, COVID happened, and so that required some deviations. Kyle, anything to add?
Just before going on, I should say, and we'll talk about this later, but when we were doing the developing and communicating with the authors, we made the decision to only replicate kind of one key result, as opposed to replicating the entire paper. So as we all know, papers have several results. We felt it was feasible only to kind of pick out the main result to replicate. And when we were communicating with the original authors, this was part of the discussion about, you know, what we thought and what they thought was the appropriate result to replicate. Okay, and then this was built into the what Blair's talking about now, the replication reports and the pre-registrations and so forth.
Yeah, that is a really good point. I mean, by no means have we attempted to replicate entire papers because we felt we had to choose something to attempt to replicate, which is what we kind of wrote up in the specific test and the specific hypothesis that we were going to replicate is what was in these replication protocols. You'll see that some of the hypotheses involve two statistical tests. So like the classic Schweitzer and Cashon, the original news vendor study, involved this too high / too low ordering pattern. And so that each one of those is its own statistical test. And so we felt that this hypothesis really was required two tests, and they both had to hold in order for the hypothesis to be replicated. So sometimes we did run two statistical tests, but we limited ourselves to focus just on one hypothesis out of each paper, which does not summarize the entire paper, but we tried to choose, we worked with the original authors to select the viable hypothesis for replication, and we tried to choose those that we felt were at least important, maybe the most important result. Recall that this happened during COVID, which made everything a bit more difficult. So we weren't sure what to do. And so because all of our labs shut, and it became clear that they were going to be shut for a while. So we decided that we either had to shelve the project or move forward in some asynchronous fashion. In some virtual fashion. And so we decided to do the following. We said for individual decision studies, we thought that group studies kind of need to be done synchronously because if there's going to be some human interaction, it may be important to physically be in the same place. And also if one person's computer lags or drops out, it would ruin the entire group. So we decided that individual decision studies were more, we're going to be more feasible to be done virtually and asynchronously. So we began those, testing those online, still with university subjects, university undergrads, just done asynchronously and online. So obviously this turns what was intended to be an exact replication into more of a close replication. So we decided to do the following. We said, if an individual decision study is replicated in this asynchronous virtual fashion, we will call that a successful replication. If it doesn't, we're going to ask ourselves, well, was the original paper done in this way? Was the original paper asynchronous? If the original paper was done virtually and asynchronously, and we just tested it virtually and asynchronously, then we would say that that was an unsuccessful replication. We attempted to replicate the paper in its original modality, and it failed to replicate, so therefore we would say this is an unsuccessful replication. If the original paper was not asynchronous, which is to say was done synchronously in a lab, then we said, well, this was only a close replication, and now let's actually conduct the exact replication. So we decided to replicate, attempt a second replication in person in the lab. If the second replication was successful, we called it successful. Without an asterisk, we just said this was a successful replication. And if this was unsuccessful, then if it didn't replicate, then we called it an unsuccessful replication. Quick note, our goal here was not to summarize 10 papers and just give a single replication rate. We wanted to add more evidence to some results that were out there and determine how robust they were. And so we certainly, as Kyle mentioned, we test only one piece of the paper, and this is not the final word on whether the papers are true or false. We simply are replicating some results and adding evidence that either kind of supports or doesn't the hypotheses we chose to test. Okay, then we decided to solicit replication rates from the community. So we sent a survey to MSOM and Behavioral Operations Management sections of Informs and asked them to assess how likely they thought it was that these papers were going to replicate. And the elicitation looked like this. We listed the paper, the specific finding to replicate. We gave some details about the replication and the subject size, and then asked, how likely do you think it is to replicate from 0 to 100? And then how confident are you in your assessment? Once we got all of that ready, then we actually ran the replications. The primary teams led the replication efforts. Secondary teams provided input and oversight, and then of course ran the studies at their sites as well. The replications reports were finalized, sent to the authors, synthesized into an initial draft of a summary paper. We posted all of the data files and analysis files to the website, which again, we'll take a look at time permitting. And the paper was published to Management Science online a few months ago and appears in the September issue. Okay, so we filled in these bits that had previously been omitted, the replication results, any deviations that were unplanned, our discussion, and all of these appear on the website. Okay, so let us talk about the results of these 10 papers. We'll start with, well, I guess at this point, why don't I hand it over to Kyle, and he can take it for a while and we'll go work back and forth.
Okay, thanks. You'll have to click the slides for me. Yeah, so in some sense, when you're doing a replication, the actual analysis is relatively straightforward, especially as we did. We had one key hypothesis, so it was a relatively simple statistical test. Now, of course, when doing this, especially because it was during COVID, we had a lot of unplanned deviations, and I think maybe at least 2 of those warrant a little discussion. And then we can go over a more of a paper by paper breakdown and kind of discuss some of the key things. Especially, I think it's interesting the papers that didn't replicate fully. Okay, so yeah, so we had target sample sizes. Okay, for all papers. For 8 of those 10 papers, we were able to achieve the target samples. 2 exceptions are the Corson and Donahue paper. For the secondary replication site, we were only able to collect the full sample at one location at UT Dallas, and at Wisconsin, the secondary site, we only got to 224 out of 255. This was a special experiment because in its original modality, it was done in a specific classrooms like Introduction to Operations Management. Okay, and Wisconsin had very hard constraints and could only do it in this one semester with all of these sections, and they were only able to achieve most of the desired sample, but not all of it, and still significantly more than the original sample of 88 participants. Okay, and then Ho and Zhang, this was again, this was a very challenging paper to replicate because of the way the experiment was designed. We needed very specific numbers of participants to show up. Otherwise, the experiment just could not actually be run. And so at the secondary site, we only were able to collect 120 out of the desired 256 participants that we wanted. But again, this was still larger than the original sample. Okay. Yeah. Okay. So if you're, I guess, just interested in the high level results, then this table is going to summarize that. It's a little bit challenging to read just because of, again, some of the challenges that we had. Okay, so the blue dot is the original replication. Okay, and the dots that are not filled are the replications. Okay, and there may be several because of the ways that we had to do it. So by our count, we have what we consider to be 6 full replications. Okay, the papers that are listed there, that is, they achieved 5% or better level of significance at both of the replication studies, or at both of the replication locations. We had 2 partial replications. Croson and Donahue replicated at one location, did not replicate at the other location. And then Engelbrecht, Wiggins, and Katok, focusing on regret, replicated at one location, but not at the other replication, at the other location. Okay, and then we had two non-replications, these being the Ho and Zhang paper and the Shenko et al. Paper. At neither replication location did they achieve 5% level of significance in favor of the tested hypothesis. Okay, and in terms of effect sizes, generally speaking, our effect sizes are less than the original studies. This is, perhaps not surprising, and it's very common with the previous replication studies that Blair talked about at the beginning. Okay, a couple achieved close to similar effect sizes, and these were the papers that had really strong results upfront in the original papers. Okay, it's perhaps less surprising to not get the full effect size in some of the studies that where the level of significance was a little bit more marginal, or the sample size is smaller. Okay.
So why don't I
Blair,
start
you wanna take it back?
just chatting about a few of, we'll take these kind of category by category. First, talking about the full replications. Again, our goal here was not to decide which papers are good or bad or right or wrong. We are not the final word. We are simply adding more evidence here. And so I think the additional evidence that we add is useful whether the papers replicate or not. And so I think there is value to be added for appreciating the results that appear to be quite robust. So here are the 6 full replications. And so we'll talk about those one by one. Notice this one data point here. So what is this? This represents an online attempted replication that did not achieve the 5% significance threshold. In Chen et al. Notice that all of the rest of the papers didn't. They all every replication attempt was below 0.05. Okay, so let's talk about this Chen et al. One, and we'll explain why it is that we call this a full replication. And it was based on our approach. So we began. This was a paper that was originally done in the lab. We, because of COVID, attempted to reproduce it asynchronously. So we did this at UT Dallas did this and found that P was less than 0.01. So we called this a successful replication. And so it replicated at UT Dallas. At Michigan, we attempted it asynchronously. It did not replicate P equals 0.08 in the asynchronous replication. Because it had originally been done in the lab, this was a close replication attempt, and so this triggered a second replication attempt in person once labs reopened. So we attempted it in the lab, and it did replicate P less than 0.01 in the lab, and so we called this a successful replication at both sites. But we publish all of the results and all of the data from all of the attempts, and so if other scientists see it differently, then you can draw your own conclusions. We discuss all of the results from all of the attempts and make it all public. So whether or not you agree with what we are calling success or not, maybe doesn't matter so much. You can go get the data and analyze it yourself. So here were the 6 full replications. Let me just kind of briefly give you an overview of what the results were that we attempted to replicate. And these are results that appear to be very strong, that replicated fully at both sites. So Chen et al. Has to do with framing or timing or something. So subjects order higher quantities under own financing versus customer financing. So here the idea is, if this negative C, if you pay the cost for each item you order, and then earn plus P, the selling price when you sell the item, then that induces one level of orders. But if we have a mathematically equivalent scheme where you get the unit margin, this P minus C, right away, but then have to repay the full selling price on any unsold units, then the ordering here is lower. These two things are mathematically equivalent because it's just a matter of timing and there's no discounting or anything. So, but we do see higher quantities ordered in the first scheme. When setting reserve prices should not be a function of the number of bidders. It should be a function of the auctioneer's valuation, but we do indeed, contrary to standard theory, find that seller chooses a higher reserve price when there are a larger number of bidders. Customers learn from other customers. So when there are informed customers that know about the quality of a service provider, for example, a restaurant, other uninformed customers who are maybe new to town will look at long lines and infer that a long line indicates high quality. They're less likely to purchase if there's a short wait, and they're more willing to sustain long waits. An empty restaurant is a bad sign, despite the fact that nobody likes waiting. System neglect. Individuals show relatively more overreaction to stable environments and more underreaction in less stable environments. We have some sort of like pull to center on how much people want to adjust forecasts. And that means they're doing too much adjusting when systems are stable and vice versa. Trust and trustworthiness in a two-tier supply chain where the manufacturer has private information. Manufacturers' messages are positively correlation with their private forecast, and suppliers' capacity decisions are positively correlated with the message received. This is a cheap talk game. The manufacturer has private information, and so they send messages that are somewhat informative, and the suppliers receive those messages, and are able to glean some of the information from those messages, even though the equilibrium should be a babbling equilibrium with no information sent. And finally, Schweitzer and Cashon, the original behavioral operations experiment, we found that indeed we do replicate the news vendor too high, too low pattern. We wondered whether we should even attempt to replicate this because there have been so many replications done of the news vendor study. We decided to for a couple of reasons. Reason one was, well, we allowed community members to vote on what they wanted to see replicated, and we thought it would be putting our thumb on the scale to remove it from consideration. So we left it in the list, and people wanted to see it replicated, so we did it. And the second is actually, I think we may have done the first exact replication, because the way this was originally conducted was kind of weird because there wasn't established norms back in 2000. So it was originally done as an Excel, as a macro-based Excel tool, which was emailed to MBA students. And the MBA students filled it out with their results being kind of tallied by VBA macros, and then they sent it back in via email. Payment was also kind of weird. I believe one student was paid a large amount, nearly $100. One student chosen at random. So it actually, so we got the original Excel document from Schweitzer and Cashon, and we were able to reprogram this using modern tools. And so it was the first kind of exact replication. Okay, now we'll talk about this next tranche here, those that did not replicate, the other end of the spectrum. Kyle will begin here.
Okay, so yeah, so Ho and Zhang, this was a paper that was talking about how the framing of a contract might affect supply chain efficiency. And so their argument is that supply chain efficiency should be higher when a two-part tariff is framed as a quantity discount rather than as just explicitly a two-part tariff, right? Like fixed fee and marginal fee. Reason being because it can trigger different ideas of loss aversion depending on how things are framed. Okay. This was by far the most challenging paper to replicate. Okay. And this speaks to some of the recommendations that we can talk about later. Okay. But in any case, the main result on efficiency that we have at UT Dallas, we actually found, I believe we found the opposite effect. In any case, we found a non-significant effect. At the secondary replication site, we found it was directionally the same, but did not meet significance. Okay, and so we, as part of this process, we shared our results with the original authors. We shared the data. They played with the data and wrote some comments, and we had a little bit of back and forth. Okay, it is true that the unplanned deviations in this replication report is a little longer than some of the others. Okay, so this experiment was originally done in a lab on pencil and paper, and the students were actually required to do all of the calculations themselves, and none of these calculations were actually checked during the experiment. Okay, we just decided that we could not do an experiment on pencil and paper, and so we computerized it. Okay, and we originally made the students, we required them to do the calculations themselves. Okay, and they could not, but we decided that we wouldn't let them proceed unless they got it correct. Okay, this was created problems. The sessions ran a very long time. And so we had to pivot that they still were required to do the calculations, but after some time, they were basically given strong hints as to what the correct answers were. Okay, so there is a difference in the procedures used. This could matter. Okay, and so we point that out. Okay, and the other thing is, again, we only tried to replicate the result on efficiency. Okay, if we had focused on some of the comparative statics about wholesale prices or fixed fees being different under the quantity discount versus the two-part tariff, these results actually do go in the same direction as the original paper. Okay, as you can see here. Okay, so wholesale prices are lower and fixed fees are higher in a quantity discount. The main driver is on rejection rates. Okay, and so we found at UT Dallas vastly different rejection rates, and in the exact opposite direction as in the original paper. Whereas Michigan, they had directionally similar acceptance rates as the original paper, but did not reach statistical significance. Okay, and I think Blair will talk about.
Yeah, the other paper that did not replicate or the other result that we tested that did not replicate is Shunko, this queuing paper. The hypothesis was that service times are shorter when customers are aligned into multiple parallel queues instead of a single pooled queue when the queues are visible and the pay is flat, and we attempted to replicate this on MTurk. At the two sites, neither one was statistically significant, and the effects were in opposite directions. This was done on MTurk. The original study was, the original paper included some treatments in the lab and some treatments on MTurk. We were originally going to replicate with university students asynchronously. The authors did not like this, and so we decided to replicate some of their original results that had originally been run on MTurk with MTurk. The difference between treatments are as follows. So we have a real effort task where you had to move these sliders to exactly 3, 4, 5. It was, fairly difficult. And then you were able to submit a cart. This was with flat payment. So these were MTurk participants were paid $3. The original study, they were paid like $1.25 or something. So we paid them $3. flat fee no matter how many carts they did. A cart is when you move all 5 of these sliders to the correct place and hit submit cart. The idea is perhaps there's a difference in your speed in doing these carts. If you have your own line, so everyone else can see your, this was an individual decision task. So by everyone else, I just mean if you have your own line versus if all of the customers are in a single pooled queue and other cashiers might help them. But there's only one human involved in this task. And we did not find evidence for this. Similar service times between these two arrangements. Many people didn't complete any carts, which makes perfect sense because they received flat fees. This wasn't discussed in the original paper. In the original paper, every single person, all of the results reported, they completed at least one cart, and they didn't talk about this data cleaning step. We eliminated these 0 carts and even still found the results here are only for people that did complete at least one cart. It appears that something has changed. I mean, potentially things could have changed in MTurk over the last decade, especially during COVID, but different people maybe are going to MTurk. Service times are higher in both replications, so it does seem the subject pool maybe is different and has changed in 10 years, which is perfectly reasonable. But we did not find evidence for this result. We're kind of running out of time, but I think we can quickly talk about some of the partial replications, which are, in some sense, particularly interesting. Kyle, is it okay if we go like a couple minutes over since we were a little late starting? Or I don't know. We'll just keep going.
Okay. So as we said, Corson and Donahue studying the beer game. And the question was, does sharing dynamic inventory information across the supply chain decrease the level of order oscillation? And then Engelbrecht, Wiggins, and Katok, this was a paper studying regret in auctions. And the result that we tried to replicate there was that if you provide information which triggers both loser regret and winner regret, that should lead to lower average bids than only providing loser regret feedback. Okay. And so for Corson and Donahue, again, this paper also presented challenges to replicate. And we did successfully replicate it in person at Wisconsin, although at a slightly lower power, again, just because of the constraints of doing it in person in the particular operations management class. Okay, and at UT Dallas, we did not replicate it, although the direction was the same. Okay, so we did not, because technology changed so much over the intervening years, we did not have access to the original interface, so we had to develop that our own. But to the best of our ability, we created a software that showed the same thing, that showed the same information. Okay, and basically in the baseline, you only had information about your inventory position and the orders that you had made and received, and the shipments that you were receiving, and the shipments that you were making. Whereas in the inventory condition, the participants were given the inventory position of all the members in the supply chain. Okay, idea being that this information should prevent you from making crazy orders because you perhaps didn't receive the shipment yet that you made a few periods ago. By seeing their inventory position, you can know that perhaps the order is coming eventually. Okay. And so the most striking difference here is that the order variance and standard deviation is much higher at both UT Dallas and at Wisconsin Madison than the original, right? So The original mean is 32 or 21, depending on the condition. In the thousands, based on the replication studies. Okay, so something fundamentally seems to have changed. Whether it was something in the software that we weren't able to exactly replicate because we didn't have access to the original source materials, or I think one of the author's conjectures is just that the nature of operations management education has changed in the intervening years. Okay, so operations management used to be a little bit more technical, a little bit more mathematical, and so the student pool was perhaps a little bit more technically capable back in the early 2000s when this experiment was done, rather than now during COVID. 20, maybe not quite 20 years later, but certainly 15 years later. Okay. Yeah, right. And again, we communicated with the original authors. And asked about outliers because we had so many outliers, but they did not seem to have outliers, and so this was again a fundamental difference. Okay. And then again, just quickly, the Engelbrecht-Wiggins and Kotok paper on regret. Again, we're calling this a partial replication, although again, this kind of shows how our procedures sort of necessitated doing this study actually 4 times, right? So it was originally done in a lab. However, we started doing it asynchronously at both Wisconsin and Cornell. At both of those locations, when it was done asynchronously, the conclusion was that that it failed to replicate. Okay, this necessitated in-person follow-ups. Okay, again at Wisconsin and at Cornell. At Wisconsin in person, it failed to replicate. Okay, whereas in Cornell in person, the result did replicate. Okay. And again, this is just showing a bit of the interface to show kind of the different triggers that these treatments were having. On the left, where there's only loser regret, okay, the feedback that you get is the average, your bid, obviously, which your value, obviously, okay. You see the average price, okay. And you see if you had any sort of missed opportunities to win. Okay, so in this case, there were none, so no regret would be triggered. But it's possible that if there were other bidders who bid at a price sort of above your bid but below your value, then this was a missed opportunity that you had to win. Okay, whereas on the right, you saw other information, and I guess because on the right, where there's both winner and loser regret, you would see the average second highest bid. Okay, and so this is kind of money that you left on the table, right? You bid 70, the average second highest bid was much less, and so you could have lowered your bid and won, and still won, but won more. Okay. Yeah. Okay, so in all cases, we get a directionally correct. The effect is directionally correct, but the level of significance is fragile. Okay, so there might be something about winner regret and triggering winner regret that is not as robust as was thought in the original paper. And I think this is maybe consistent with some of the other studies on regret out there. That we know that sort of winner regret is weaker and more fragile, I think, than loser regret is. Okay. Okay, and let's let Blair talk about the prediction.
Yeah, in the interest of time, let me just say something very briefly about this prediction survey. We were interested in, could folks in the field predict how well papers were going to replicate? overall, they did fairly well. Those in the, I'm sorry, those in overall, people thought that there was about a 71% chance on average that papers were going to replicate. Those in the BOM community, those who had published a behavioral ops paper in the past, were more bullish, thought it was more likely papers were going to replicate. Okay. And for papers that replicated, there was on average 74% of people thought they would. For those that didn't, 68%. So there's some discrimination here that's possible. But in the interest of time, let's wrap it up here. The paper was published in the September edition of Management Science, so it's kind of hot off the press here. It included a blog post from Colin Kammer and Yan Chen. Economists are known for being, no offense, Kyle, curmudgeonly. And Colin Kammer said, this comment opens his commentary with this. This comment cheerleads and historicizes the superb action-packed paper by Davis et al. And so that's a lot of superlatives for one famous economist. So we are, the paper is new and we're still kind of seeing what comes of it. As we have tried to mention throughout, and Kyle, if you have any comments along the way, please feel free to add in here. We weren't able to replicate entire papers. We just had to pick one result. We only chose papers from one journal. It's only 10 papers total. And so this is necessarily a limited effort, but also this was about half of the papers that we, nearly half of the papers that we identified as possible. So it's should be pretty representative of the 24 feasible papers we were initially identified from Management Science. We did allow community members to help us pick the papers, and there's yet more to be done. Kyle, do you want to say anything about best practices?
Yeah, I mean, again, the main thing to say is just from doing this exercise, some of the authors were very organized, had original materials, gave us everything. And some of it was, there's a recency bias, obviously, in some of this. And those papers were, very easy to replicate. Other papers, again, partially because of lapse of time and whatnot, were just much more challenging to replicate. So I do think that it's important as researchers that, again, it's their act as if your study will be replicated in the future. Okay. And, one can do things to facilitate that, right? By making their experimental designs flexible. Okay. By making their experimental, by sharing all of the materials, okay, source material when possible, or just, screenshots, if not possible. Okay. So again, part of the challenge with replicating the Ho and Zhang paper and doing it in an exact fashion was just that it had to be done with exactly 11 or exactly 12 participants. Otherwise it couldn't be done. Okay. One does not need to design an experiment like this, I think, in most cases. Okay. So it's just to put out there that we should think about creating designs that are conducive to replicability, right? Because again, I just think that if that's the case, that will hopefully lead to more trust in the underlying results also.
There's been a discussion here on the chat about p-values. I think p-values are useful because we're accustomed to them, but also I think they're insufficient, especially when we just say p less than 0.01. So I think including more statistics, including raw data and your analysis files, including test statistics, I think just including more details about what the analyses are the decisions that were made pre-registration, limiting the number of experimenter degrees of freedom so that we kind of tie our own hands and try and adhere a little bit better to the scientific method. I think there's already a movement underway. And so we just would like to underwrite all of this. Okay. I think we have published all of the raw materials, all of the data we collected on our website, msreplication.com. This could be a useful, in addition to in addition to the replication benefits, this also now gathers a bunch of data that is like guaranteed p hacking free in one place. So it could be useful for a PhD seminar. If you want to, we publish all of our data in R files to show how we do the replications. You can, or the statistical tests, you can try it yourself. And so, yeah, but a benefit of this is to have a whole bunch of data publicly available all on one website, along with all the replication reports and the paper itself, of course. We got lucky, or kind of unlucky. It just so happens that recently you can't look at a major news outlet without seeing discussions of academic integrity, dishonesty, fraud, etc. This was not, we weren't looking for fraud. We didn't find any evidence of fraud, but I do think as there's this was my cell phone a few days ago. The very first thing on Wall Street Journal's app was the data colada folks. So I think this is coming into the public consciousness. And so science is self-correcting. And I think replication studies are one of the ways that we can self-correct. So I feel like I feel quite lucky to have been part of this team. And I think this is a useful effort to kind of establish solidly something about at least these 10 papers that were included in management science. I apologize for going over all, but we got through it. Probably questions are out of the question given how far over we are, but I will leave that up to whoever. Okay. I don't know. Should we just call it? Kyle, do we want to do any questions? Seems like we're already quite late.
It's up to the organizers, but yeah, but thank you for sticking with us through the technical difficulties.
That's right. That is right. Okay. Well, check it out. Please feel free to reach out to us if you have any questions. We try to put as much information as we possibly could on the website, msreplication.com. So if you would like to see what we did, it's all there. Okay. Well, like Kyle said, thank you all so much for having us, for bearing with us, for trying to get into this meeting over and over. We finally made it. Okay. We'll go ahead and call it. Thank you all.
Thank you.